Hey, welcome. So today we are talking about what might just be the most perfect shape in the entire universe, the circle. I mean, look at it. It's so simple, so clean, so elegant. But hidden inside that perfect curve is this whole set of secret rules, an entire geometric language that is unbelievably powerful. Okay, let's dive right in. So, you have to wonder, what are these rules, really? How do lines and angles actually behave when they're stuck inside or maybe just touching this perfect shape? Well, we're about to pull back the curtain and explore the beautiful, almost invisible logic that's been hiding there in plain sight all along. Here's how we're going to tackle this. First, we'll start with the basics, looking at the lines that live inside a circle. Then, we're going to completely shift our perspective and see what the view is like from the edge. And finally, we'll unlock the really surprising power that these angles have. It's a journey to the circle's deepest secrets. All right, first up, let's get to know the absolute fundamental building blocks. We're talking about chords, those lines that cut straight across the circle, and tangents, the lines that just barely kiss its edge. As simple as they seem, these lines follow some very strict and very cool rules. So check out this first rule. It's actually super practical. If you draw any chord, literally anyone you want, and then you draw a line that cuts it perfectly in half at a 90-degree angle, well, that line is absolutely guaranteed to run straight through the circle's center. It's a geometric certainty. It's like a cheat code for finding the exact heart of any circle. This next one is all about the circle's perfect, beautiful symmetry. If you have two chords that are the exact same length, they have to be the exact same distance from the center. It's just a rule of balance. And get this, it works the other way around too. If two chords are the same distance from the center, you know for a fact they have to be the same length. So simple, so consistent. Okay, let's step just outside the circle for a second. A tangent, remember, is a line that touches the circle at exactly one point. Now, if you pick any spot outside the circle, you can draw two lines from it that are tangent to the circle. And here's the magic trick. The length of those two tangents, from your point to where they touch the circle, will always be identical. And for anyone out there who just has to know why this works, the proof is actually incredibly elegant. So if you draw lines from the center to those points where the tangents touch, you instantly create two right-angled triangles that are perfect mirror images of each other. Think about it. They share a side, and their other two sides are the radii, which are, of course, identical. That means the triangles themselves have to be identical. And if the triangles are identical, well, then the tangent lines, PA and PB, must be the exact same length. It's just beautiful, airtight logic. All right, we've got a handle on the lines. Now let's totally switch up our perspective. We're going to move away from the center of the circle and go stand right on the edge, on the circumference itself. And this little shift in our viewpoint, well, it's about to reveal the most important rule of all. So first, let's get our bearings. A central angle is what you see when you look at a piece of the circle's edge, an arc, from the very center of the circle. You can think of this as the official angle of that particular arc. It's our baseline. Now, an inscribed angle is the view of that exact same arc, but this time you're seeing it from a point somewhere on the opposite edge of the circle. So we've got two different views of the exact same thing, one from the center and one from the edge. So, what do you think? How does that angle you measure from the center connect to the one from the edge? I mean, they're both looking at the same piece of the circle, right? There has to be a relationship there, and oh, there absolutely is. The inscribed angle is always, and I mean always, exactly half the size of the central angle. That's it. This is the whole ball game. This simple little fraction is the master key that unlocks pretty much everything else about angles in a circle. You have to remember this one, because everything that comes next is a direct result of this single idea. Okay, we've got our master key. Now it's time to actually use it. Let's see what kind of powerful and kind of surprising properties this one little rule unlocks. This is where the real magic happens. So, discovery number one. If you have a whole bunch of inscribed angles and they're all looking at the very same arc, they all have to be equal. Why? Well, because they're all half of the same central angle. It doesn't matter where you're standing on the edge of the circle. Your view of that arc is always going to have the same angle. Now for a really cool special case. A semicircle, right, is just an arc whose central angle is a straight line, which is 180 degrees. So what's the inscribed angle looking at that arc going to be? Well, it's got to be half of 180, and that is 90 degrees. A perfect right angle. Every single time. This is a game changer in things like construction and design. Okay, so what happens when we trap a shape inside a circle? A cyclic quadrilateral is basically any four-sided shape where all four of its corners are touching the circle's edge. And because it's completely confined by that circle, it's forced to follow some very special rules. Right, so being trapped like that leads to two big things. First, its opposite angles always add up to exactly 180 degrees. It's a rule. And second, if you extend one of the sides out to create an exterior angle, that new angle will be exactly equal to the interior angle at the opposite corner. These two properties are just part of the deal for any four-sided shape you can draw inside a circle. Let's look at one last really elegant rule. It's sometimes called the alternate segment theorem. And what it says is that the angle you make between a tangent and a chord, right at the point where they touch, is exactly equal to the inscribed angle on the far side of that chord. It's this beautiful little bridge that connects the lines outside the circle with the angles deep inside it. So let's put this all together. What we've just done is assemble an incredibly powerful toolkit for understanding circles. From finding the dead center of a circle to predicting literally every angle inside it, each rule, especially that half-angle master key, builds on the others to show us the simple, predictable, and beautiful logic hidden in this amazing shape. And that really brings us to our final thought. Now that you know these hidden rules, I promise you, you are going to start seeing them absolutely everywhere. So how are these precise, unchanging laws of geometry being used right now? To build our cities, to navigate the stars, even to create art. The fundamental logic of the circle is all around us, just waiting for us to notice.